Hello everybody, I would like to welcome you to our 7th video in the pre-algebra playlist. And in this video we will go over an important concept known as exponents. Now, out of everything that you have learned so far, including addition, subtraction, multiplication, and division, the concept of exponents is most closely represented by that of multiplication. Now, there's no real definition per se for exponents, but the way in which you perform the operation of exponents can be defined as this over here. So the way in which you perform the operation of exponents can be defined as multiplying the base number by itself that many times. Now, what do I mean by all of these words right here? Well, the notation in which you're going to find most of your exponents will be in this form right here. So this weird notation over here is how you are going to find most of your exponents. The number 1 over here means the base. On the other hand, this number right here, number 2, is called the exponent of the problem. So let's do a couple of examples so that you get a better understanding of the meaning of exponents. Let's say I want to find what 3 to the second power is. Now, the number 2 over here is read as to the power of. So, if you have something like 3 and the 2 on the top over here, that is read as 3 to the power of 2. Another word for the word exponents is power. So exponents are the same thing as power. So let's evaluate now what 3 to the power of 2 is equal to. Going back on how to evaluate exponents, it tells me to multiply the base number by itself that many times. So I need to multiply 3 by itself 2 times because 2 is the exponent in this problem. Therefore, my solution is simply 3 times 3. And that gives me 9. Let's now say I want to find out what 5 to the power of 3 is equal to. So 5 raised to the power of 3 is the same thing as saying 5 times 5 times 5. We learned in the previous videos that when you're multiplying 2 or more integers together, the proper method of solution is to multiply the first 2 together and move on like that from left to right. So you multiply this 5 and 5 over here together to give you 25. Next thing, you multiply it by 5 to give you 125. Let's do one more. Let's say I want to find out what 8 to the power of 4 is equal to. So I can write 8 to the power of 4 like this over here. So when I start multiplying the 8 by itself 4 times from left to right, the first 2 gives me an answer of 64. Now, when I multiply 64 by 8 again, that gives me 512. In the last step, I need to multiply 512 by 8. And when I do that, I get 4096. So my answer to 8 to the power of 4 is 4096. So now that you know how to perform the exponent operation, let's go over a couple of properties that hold true regarding exponents. For the purposes of this video, we are only going to discuss 2 of the several properties of exponents. By now, you know what it means for a number to be odd or even. When it comes to exponents, if the base is odd, then the answer will always be odd. And similarly, if the base of the exponent problem is even, then the answer will always be even. Okay? Now let's see what happens if we throw the negatives in the mix with the exponents. So there are basically 3 different ways in which you will see negatives in the mix when it comes to exponents. One of them is that there is a negative in front of the entire exponent problem, such as this over here. If you find such a case, what you need to do is simply ignore the negative out in the front, evaluate the number 1 raised to the power of number 2, like you would with any other exponent problem, find the answer, and then in the end, just put a negative right next to the answer. So in this case, if there is a negative in front of the entire exponent problem, the answer will always be negative. One of the other ways in which you can find a negative with the exponents is like this over here. In such a case, when the base number itself is a negative number and the exponent is a positive number, the answer really depends on whether the number on the top or the exponent is odd or even. So, if the exponent itself is odd, then the answer will always be negative. Similarly, if the exponent of the problem is even, the answer will always be positive. A third way in which you can find negative relating to exponents is if the exponent itself is a negative number. In such a case, the sign of the answer really depends on if the number 1 is positive or negative. If number 1 is positive, then the answer will always be positive. And similarly, if the base itself is a negative number, the answer will be a negative number. Now something really cool happens when you're dealing with the third type of the negative in the exponent mix over here. If the exponent itself is a negative, such as in this case over here, an equivalent way of writing the problem is like this over here. 1 divided by the exponent problem without the negative exponent. So with the first scenario, let's say you have something like negative 3 raised to the power of 3. Since in this case the negative is outside the parentheses, the answer will always be a negative. So all you need to do now is evaluate 3 raised to the power of 3, find the answer, and simply put a negative out in the front. You know by now that 3 raised to the power of 3 can be rewritten as 3 times 3 times 3. And this will give you 27. So all you need to do now is just put a negative out in the front and your final answer is negative 27. Let's do another example like this. Let's say you have negative 4 raised to the power of 4. In this case, you know that this thing over here can be rewritten as negative times 4 times 4 times 4 times 4. All you need to do now is evaluate the inside of the parentheses and then simply put a negative out there in the front. So 4 times 4 gives you 16. 16 times 4 will give you 64. And 64 times 4 will give you 256. Now all you need to do is put a little negative out in the front of the number 256 and your answer becomes negative 256. So let's do another example, but this time dealing with the other negatives that are possible when it comes to exponent problems. Let's say you have something like this over here. In this case, unlike the examples that we did on the top over here, the negative is inside the parentheses. In this case, this is the same thing as saying negative 5 times negative 5. And referring back to the last page, you know that if you're presented with such a problem, in which case the negative is inside the parentheses and the exponent is an even number, the answer will always be positive. So, negative 5 times negative 5 will give you an answer of 25. Let's do another example. Let's say you have something like negative 7 raised to the power of 3. Referring back to the last page, and in the second scenario with negatives being related to the exponents, you know that this answer will be a negative number, so you can rewrite this as negative 7 times negative 7 times negative 7. You multiply the first two negative 7's together to give you 49. Then you multiply the third negative 7 together with 49 to give you negative 343. And so this is your answer right here. Now let's do another example, but this time let's make the exponent the negative number. Let's say you have something like 2 raised to the negative 4 power. In this case, you can rewrite this problem over here like this over here. So you can evaluate the 2 to the 4 first and then simply divide 1 by it. Therefore, you know that 2 to the 4 is the same thing as saying 2 times 2 times 2 times 2, and that gives you 16. So your final answer will be 1 divided by 16. For those of you who have been already exposed to fractions, you can rewrite this more commonly as 1 over 16. Now, let's say you want to find the answer to what negative 3 raised to the power of negative 4 is equal to. What you can do is that you can simply ignore the negative out here in the front and evaluate 3 to the negative 4. That is the same thing as saying 1 divided by 3 to the 4. When you evaluate 3 to the 4, by now you should be getting the hang of it and get the answer of 81. So your final answer turns out to be 1 divided by 81. A more common notation of writing this answer can be done using fractions. So another way of writing your final answer of 1 divided by 81 is like this over here. And so there you have it. I hope you learned a lot from this video and you enjoyed it thoroughly, and I hope you keep on working hard, and I'll see you in the next video.